All right, continuing where I left off before. This is number 13. I got interrupted, had to teach some kids and stuff like that. So you got to stop making your YouTube videos to educate the public. So here we go. This is after school hours now. 3 comes up here. It's log x to the third, and then minus 6 would be dividing by 6. I'll put that in the next step, and then multiplying by 2.4. So I'm going to do that all in the next step, equals 9. So it's going to be log the multiplication, so it's 2.4 x to the third over 6 is equal to 9. Remember, this is log base 10, so it's going to be 10 to the 9th power is equal to 2.4 x cubed over 6. Multiply the 6 over, and then divide the 2.4, and then take the cube root to get x by itself. So I'm going to multiply 6 over.
High school staff.
All right, interrupted by an announcement. Here we go. Multiply the 6 over. So we get 6 times 10 to the 9th is equal to 2.4 x cubed. We're going to divide over the 2.4. So it's 6.9, or 6 times 10 to the 9th over 2.4. And now we got to take the cube root of that. So it's x cubed. Do the opposite, take the cube root of each side. So that's the answer. It's the cube root of 6 times 10 to the 9th over 2.4. So x is approximately equal to 1357.209. Oh, I could have moved this over a little bit more. I got like plenty of room. So it's 1357.209. All right. We're going to bring the logs to the same side of the equation because I can apply the property then. So I'm going to subtract this log over. When you subtract the log over, then equals 1. Because I subtracted the log over, it's now equal to 1, not plus 1. Since this is subtraction now, this changes into division. Is equal to 1. So that's an equal sign there. 10 to the first power is just 10. So 10 is equal to 7x plus 1 over x minus 2. So it's base exponent answer as before. Multiply. Think of this as like a proportion. So this times this is equal to this times this. So the cross product, this situation. So 10 times x would be 10x. 10 times the 2 would be minus 2 is equal to 7x plus 1. So I distributed. I did 10 times the x and 10 times the 2, which would be 20, not 2. 10 times x, 10 times the negative 2. All right, I'm going to subtract over, get the variables over on the same side, subtract 7. So we get 3x minus 20 is equal to 1. Add the 20 over, 3x is equal to 21. Divide, x is 7. All right, not having good solving here, I keep making mistakes. So maybe just hang in there, I'll get on a roll again. Number 15 is 7 to the second power is equal to 2x minus 3 to the second power. So I went base exponent answer. To get rid of the second power, take the square root of each side, which when you take the square root of something squared, that's plus or minus, so it's plus or minus 7. It's not really 7, is equal to 2x minus 3. Add the 3 over, plus or minus 7 plus 3 is equal to 2x. Divide the 2 to get x by itself. So it's negative plus or minus 7 plus 3 over 2. 7 plus 3 is 10, divided by 2 is 5. Negative 7 plus 3 is negative 4, divided by 2 is negative 2. So there's two answers, 5 and negative 2. And it's okay to put a negative back in here because you're going to get a negative answer, but you're squaring it before you take the log of it. So that's okay. You can have the negatives with that. The next problem is base exponent answer. 2 to the exponent 3 is equal to x squared plus 2x. So it's 8 is equal to x squared plus 2x. Move the 8 over, because this is a quadratic. We solve our quadratics by setting them equal to 0. So you get x squared plus 2x minus 8 equals 0. Each side, or this can now be factored. If you couldn't factor, you use the quadratic formula, of course, to solve it. And plus 4 minus 2, 0 product property. We set each factor equal to 0. And we get negative 4, and x is equal to 2. All right, continuing on. This one here, just base exponent answer, solve the quadratic, base exponent answer, solve the quadratic by taking the square root. On this one we did the factoring. We arranged it, turned it into an algebra problem, basic algebra 1 problem, and here this one was kind of a hot mess. That was kind of a bad way to start the video, those hot mess ones. Now we're going to do an easy one. Anytime there's e, we want to do natural log instead of log, because the natural log of e is equal to 1. So that makes it much easier to solve. So I take the natural log of each side of the equation. That brings the x to the front, so we had x natural log of e is equal to the natural log of 18. But the natural log of e is 1. 1 times x is just x. So essentially, x is now by itself. So x is equal to the natural log of 18, which is approximately equal to 2.890. Boom. Before we take the natural log of each side, I'm going to subtract the 7 over. So e to the x to the 5th is equal to 3. Take the natural log of each side, and we get x over 5 natural log of e is equal to the natural log of 3. Now I just multiply 5 over. So the answer is x is equal to 5 natural log of 3, which is approximately equal to 5.493. This one here, I don't have to change anything first, but I do have to take care of this. But that's protected. I'm not allowed to touch that until I bring it down. So take the natural log of each side. X plus 1, natural log of e is equal to the natural log of 30. That's 1, so it's x plus 1 is equal to the natural log of 30. Move the 1 over by subtraction. Natural log of 30 minus 1. Natural log of 30 minus 1, x is approximately equal to 2.401. By typing this into the calculator again. Number 20, I'm going to clean it up a little bit. I'm going to subtract the 7 over. So negative 2 e to the x over 2 is equal to negative 6. Divide each side by negative 2 and get e to the x over 2 is equal to 3. So you always want to clean up the algebra before you do the fancy step. And the fancy step is to take the natural log of each side. I'll highlight that in orange. So it's x over 2 natural log of e is equal to the natural log of 3. That's just 1. Multiply the 2 over to get it by itself. So it's a natural log of 3 times 2. So x is 2 natural log of 3, which is approximately equal to 2.197. Exact answer, approximate answer. I'm going to clean this one up by adding the 8 over. So I'm going to add over 8 to each side. That gives me 14. Then I'm going to take the natural log of each side. So I get x over 9 natural log of e, which is just 1. It's equal to the natural log of 14. I'm going to multiply 9 over to get it by itself. Multiply by 9. So x is equal to 9 natural log of 14. Type that into the calculator. X is approximately equal to 23.752. This one's pretty straightforward, but I can't touch the 2 until I take the natural log of each side. So I get 2x natural log of e is equal to natural log of 10. That goes away because the natural log of e is 1. Divide the 2 over, so x is equal to natural log of 10 over 2. By typing that in the calculator, we get 1.151. Down here, we're going to go base exponent answer to solve these. Just like on the other worksheet, the base is e for natural log. Remember, if it's log, it's just base 10, but natural log is base e. So it's e to the 6th power is 3x. Solve for x, divide by 3. So it's e to the sixth power divided by 3 is the exact answer. So x is approximately equal to 134.747476. E, so it's e to the 36th power is equal to 4x minus 1. Add the 1 over, e to the 36th power plus 1 is equal to 4x. Divide by 4. That's the answer. To put it in the calculator, make sure you put parentheses around that if you're typing it all in at once. The answer is really huge on this. It's ridiculously large. It's 1.078 times 10 to the 15th power. The base is e on this one, so it's e to the third is equal to 4x squared. Now, it's okay to say that the answer is negative on this one because you're going to square the negative. So we get two answers for this, a plus and minus answer. Divide the 4 over, e to the third power divided by 4 is equal to x squared. Then we take the square root of each side, which yields a plus or minus answer. So it's plus or minus square root e to the third over 4 is equal to x. So x is approximately equal to 2.2 plus or minus 2.241. All right, last page, 5 problems. We are getting close. This one here, very super straightforward. E to the negative 2 is equal to x. We type that into the calculator. X is approximately 0.135. Now remember, negative exponent doesn't mean negative number, it means fraction. So it's basically, it's 1 over e squared. So that's a fraction, and it just makes that yucky decimal. All right, so I'm going to subtract over the 1.1 because I'm isolating here. So I get natural log of x squared is equal to 4.9. So e is the base, so e to the 4.9 is equal to x squared. Then we take the square root of each side, and we get plus or minus square root e 4.9 power is equal to x. We type that into the calculator, and we get approximately equal to 11.588 with the plus and minus in front. Now it's okay to have a negative because I'm going to square the negative before I take the natural log of it. This next one here, base is e, exponent is 8, is 2x plus 3. I'm going to subtract the 3 over and just divide by 2. So it's e to the 8th power minus 3 over 2 is equal to x. And again, if you're typing this into the calculator, make sure you have extra parentheses there if you're going to type it in all at once. So x is approximately equal to 1488.979. Okay, the last two problems. I'm going to make this all one natural log at the same time. So it's x, that's the 1/3 power. You're going to multiply it by 2, and you're going to divide it by 3. So that's what that means. That means dividing by 3. That means multiplying by 2. That means the power. That's all natural log is equal to 3. So I condensed it together. E is my base. So I say e to the 3rd power is 2x to the 1/3 divided by 3. I'm going to multiply the 3 over. So it's 3e to the 3rd is equal to 2x to the 1/3. Divide by 2. And that goes away. Then I'm going to cube each side. So raise everything to the 3rd power to figure out what x is. So if I cube this, I get 27 e to the 9th, 3 times 3, and then over 8 is equal to x. Type that into the calculator, and it's 27,347.908. Large, huge number. This next one, I'm going to go ahead and condense it down again. That means division. So it is log, not log, but natural log, x plus 2 divided by 4 is equal to 3. So my base is e, so it's e cubed is equal to x plus 2 over 4. Multiply the 4 over x plus 2, because I multiply each side by 4. Get rid of that. And then I'm going to subtract the 2 over, so it's 4e cubed minus 2 is equal to x. Type that in the calculator, and we get 78.342. In any of these problems here, these x's, you can put it right back in, type it in, and you should get something very close to 3 because of the rounding. It's not going to be exact, but it's pretty close. All right, so there's 30 problems all to do with solving exponential and log equations.